When you make a sound, you create vibrations in your throat. Those vibrations travel out of your mouth and reach the balloon, making it vibrate too, even if the balloon is a few feet away. So sound vibrations do travel through the air. In fact, your ears work similar to this balloon. Inside your ear is a little part made of thin material, just like the thinness of a balloon. It's called your eardrum. When someone or something makes a sound, the vibrations from that sound go through the air into your ear and then make the eardrum vibrate, just like a drum vibrates when you hit it. Whenever your eardrum vibrates, that sends a message to your brain, letting you know you're hearing a sound. Now, you might wonder, if sound vibrations are in the air all around you, why can't you feel the air shaking? Or see the air vibrations even? Like if someone talks to you or if someone plays music, could you notice someone's hair vibrating back and forth? Well, maybe the vibrations are just too small to notice. Maybe if we made the sounds louder, then we'd notice something. So let's see. Now this person is going to hold a balloon over a speaker with really loud music coming out of the speaker. It's going to be just like the experiment you tried, but with louder sound. Now I've turned the sound off so that you can just see what happens. You ready? Here we go. You see that? The entire balloon jiggles back and forth, so you can really see the vibrations. Now, let's see if it gets even louder. Here's a birthday balloon in someone's car when someone's blasting the radio. Now this time I've got the sound on, but not so loud that it hurts your ears. You would not want to be in this car without ear protection. You can really see those vibrations, can't you? Well, what happens if the sound gets even louder? Could the vibrations be big enough to... You know where I'm going with this, right? Keep an eye on this windshield. Watch as these people, who by the way, really ought to be wearing ear protection, experiment with the vibrations from the really loud speakers in the back of their car. Now here's a close-up of the speakers. Watch what happens. That windshield is a goner. And here's one more time. This time, this person is wearing ear protection. And they've got an old car where they're going to see if they can deliberately make that windshield shatter as quickly as possible. Ready? Watch.
Is he ready? Ready. Here we go.
Whoa. So the vibrations from the speakers are traveling through the air and are actually making the windshield vibrate back and forth? Really? How is that possible? I realize you couldn't see inside this car, but I'm telling you, there's no big gust of wind going from the speaker to the windshield. All you could see is the speaker going back and forth and the windshield cracking and moving. Now, one way to figure out what's going on is to make a model that shows something that you can't see using things that you can see. So in a minute, you're going to do an activity. You're going to make a model that uses people to show how sound travels from a car's speaker, this person will act as the speaker, through the air, these people represent little sections of the air, over to a windshield and break the windshield. Now in this activity, different people will play different parts of the problem you're trying to figure out. If you're in a classroom, your classmates can play the parts. If you're air blobs, pass the wobble along until it reaches windshield. Give it a try. Here's our idea. Speaker, wobble back and forth and push on the first air blob. Air blobs, pass the wobble along until it reaches windshield. When you make a sound, you really are making vibrations go across a distance. Now, in the case of talking into a string, or in the case of making a sound underwater, you know that there's some stuff or material that the sound is vibrating. The sound vibrates the string, or the sound vibrates the water. But when we're just talking to each other in a room, we don't think of sound vibrating anything. We forget the fact that there is a material around us all the time: air. So what would happen to sound if there were no air? If there were nothing? Just emptiness. We could totally find out if only we could find a place without air. Can you think of a place where we could do that? Maybe you're thinking of outer space. There's no air in outer space, so we could do the experiment there. It's just a little hard to get there. Luckily, there's a device right here on Earth that can create the same condition as outer space. It's this, a device called a vacuum pump. If that makes you think of one of these, that's actually not too far off. This is a vacuum cleaner. That uses suction to get dirt off your floor. Well, a vacuum pump is just stronger than that. Instead of sucking up dirt, a vacuum pump can be used to suck the air out of a container. So let's try it out. This vacuum pump is hooked up to underneath this little table so that it will suck all the air out of this space. If you put a bottle in here with a little hole drilled in the top so that air can escape, watch what happens when you turn the vacuum pump on. Ready? The vacuum pump sucked all the air out of the bottle, leaving it completely empty. That's actually what the word vacuum means. It comes from the Latin word for empty. So by turning the vacuum pump on, inside this jar, we've created the same condition as outer space, where there's no air. So what if we made a sound inside the jar and took out the air? What would happen? This is a bell. Hear that? Right now, there's air all around it. So let's take it all out. First, we'll turn on the bell, and then we'll put it inside a jar. Then we'll turn on the vacuum pump, and it will start to suck out all the air. Okay, it's sucking out all the air, so listen. What happens as it does that? You hear that? There's no air left inside now. The bell is still dinging, it's not broken, but you can't hear any sound at all. You just hear the sound of the vacuum pump. So if we put the air back in, what do you think will happen? Now the air is coming back in. Ah, you hear that? And the sound is back. So you can hear sound through air, but you can't hear sound in empty space. Why do you think that is? Why can't you hear sound in empty space? Well, if we think again of the idea that sound is a vibration, you can make sense of this. Because in order for there to be a vibration, there has to be something, some material or stuff, which is being vibrated. A string can vibrate, water can vibrate, even air can vibrate. But empty space? If we remove the air, then there's no way for sound to travel, because there's no material to vibrate. Sound is a vibration. If there's no material, there'll be no sound. Keep that in mind next time you watch a movie where you hear a spaceship blowing up, like this. Really, it should sound more like this.